Ooh, okay. Now a different idea. Or if this is a different video, a completely different idea. Okay. Write the equation line tangent through 0, 2. Well, if the slope is this, so dy dx at 0, 2, so dy dx at 0, 2 is going to be negative 1. So the tangent line is going to be y equals the y value minus the slope, x minus the x value, and the x value is 0. Use that tangent line to approx y of 0.5. So y of 0.5 approximately is 2 minus 0.5, which is 1.5, or 3/2. But we're using decimals here, so I'll roll with that. Okay. Use the approximation you found to approximate the tangent line. So that means dy dx at x equals 0.5 is roughly 1.5 minus 3 is negative 1.5. So then the tangent line would be y equals the y value minus the slope, x minus, what was the x value? 0.5. And then y at x equals 1, or I guess I could just say y of 1 because that's the notation they're using here. Y of 1 equals 1.5 minus 1.5 times 0.5, so that's 0.75. Okay, so what we just did is we found a tangent line. We used that, so if that was tangent to the point here, the curve there, we used that to approximate slightly later, and then we formed a new tangent line and used that to approximate slightly later. So something like that sort of picture. Hey, that's what I was just talking about. So these tangent lines, so this is their first tangent line. Use that to find the next tangent line, and then the next tangent line, and then the next tangent line. So you're getting a little bit farther off in terms of the error, but you're getting an estimate of what the value is. So feel free to read that, pause the video, whatever you need. All right, given the differential equation, find the approximation for y equals 1, 2 steps. So 2 steps. So dy dx at x equals 0 is 2. So then the tangent line is y equals the y value plus the slope, x minus the x value. And then let's go to dy dx. Let's see, where are we going? We're going to 1, but 2 steps. So my first step is going to be to 0.5. Because if I'm going from 0 to 1 in 2 steps, those are going to be equal steps. So I got to go to 0.5. So that's going to be 2.5. And then y of 0.5 is going to be approximately 3 plus 2 times 0.5, so 4, which means we'll have y equals 4 plus 2.5, x minus 0.5. And then if we have y of 1, that's approximately 4 plus 2.5, 1 minus 0.5. So that's 4, and then half of 2.5 is 1.25, so 5.25 would be my approximation. So what I did is I used this differential equation to form this first tangent line. Then I used the rough tangent line to give me a y value and a slope and formed a new tangent line. Then I used the new tangent line to give me a approximate y value. Okay. Solve the diffie-q and use it to find your solution, okay? So I have dy dx equals x plus 2, so I'm going to rewrite that as dy equals x plus 2 dx. Let's integrate both sides. I'm writing that way so that we can kind of reiterate our separation of variables. So that's 1 dy, so that's y equals 1/2 x squared plus 2x plus some sort of constant. We have 0, 3, so actually the constant is easy. If I plug in 0 for x, I get 3 out. And then we want to know y of 1. So y of 1 is going to be 1/2 plus 2 plus 3. Hey, I was adding already, which is 5.5. So then the error is 0.25. Because it says the error is the difference between approximate and exact value. So the error was 0.25. How could I produce a smaller error? Ooh, that's a great question. How do you think we could produce a smaller error? I'm pausing for dramatic effect again. I hope that you're thinking, oh, if I made more tangent lines, I would have a smaller error. Ooh, this is your job. Try this out. So pause the video, try this out, ask questions. Well, actually, don't pause the video because I'm all done. And ask questions if you are confused.